Hello everyone, we'd like to present the final results of our political geometry project. I'll be giving a brief overview of the scope of our analysis and the questions we focused on. Then Klaus will talk about the visualizations of co-sponsorships and Leo will explain our spectral clustering method. So our main focus was the US Senate between the years 1973 and 2022. We were mainly interested in finding out how members from the Republican and the Democratic faction worked together. Our main source was the co-sponsorship data, and we looked into the bills that were introduced to the Senate that had the support of both parties. And the central questions we tried to answer were: how did the cross-party cooperation change over time? What clusters can we identify? And what are policy areas with high or low rates?
So after this short introduction, I will start to present our results concerning cross-party cooperation. We use different ways to measure that. For this graph, we are looking at the significant co-sponsoring relations between Republicans and Democrats and took this number as a foundation for measuring cooperation. And in this graph, higher values here indicate more cross-party cooperation. And down here you see the Senate periods analyzed. Different colors indicate whether the president's party had a majority in the Senate during that time or not. And yeah, here on the top you see who was US president at that time. And we definitely see that there have been ups and downs when it comes to cross-party cooperation. However, one thing that is quite striking is that over the past 12 years, there has been a quite low number in cross-party cooperation. And we try to illustrate these changes in cross-party cooperation with different graphs, and we used Gephi to create these graphs. And first we want to look at the Senate period 1985 till 1987. If you remember the graph we've just seen, that was a period with a quite high number of cross-party cooperation and cross-party co-sponsorings. And yeah, I'm going to explain this graph to you very quickly. So the dots represent senators and the edges represent co-sponsoring relations between the senators. And the senator names are colored according to their party affiliation. And what we did is we used the clustering algorithm to determine clusters, and we got 3 different clusters on the graph, and we call it the dots according to which cluster a senator belongs to. And what we can see is, even though senators might belong to different political parties, there are quite a lot of connection lines in between of senators of different parties. So overall, this Senate seems to be quite connected in that sense. However, the Senate period 2019 until 2021 gives us an entirely different picture. So we see that the two parties are quite separated, and there are not that many connection lines in between of them. So we definitely see that there has been drastic changes in cross-party cooperation. And another field we were looking into was the following. So we were asking ourselves which policy areas contribute most to cross-party cooperation, and this graph tells you more about that. So on this axis we have a percent scale, and what it tells you is, out of all bills that were created by cross-party cooperation, what percentage originated from different policy areas. And we can see that, for example, labor or social welfare are areas where not that much cross-party cooperation was going on. However, for example, international affairs has some really big numbers sometimes, and that indicates that external factors and global happenings might influence parties and make them work together.
Now we use a method called spectral clustering to get a protection of our n-senators in the n-dimensional space. We want to get a vector A for every of the senators, and we want that vectors minimized this function, so a huge number of co-sponsorings W between two senators means that these two senators have a small distance in the n-dimensional space. We can solve this problem by solving an eigenvalue problem, and then we can plot the first two axes, and we get this plot. The red dots stand for Republicans, the blue dots for Democrats. And as we can see, it works pretty nice. So this mathematical model splits the senators in the two factions. We know. Now we can calculate some measures. The first two measures, here we have that a huger measure means a huger similarity of these two factions, and by measure 3 we have a case that a huger measure means a huger dissimilarity of the two factions. For the 117th Senate, we can calculate the following numbers for every political area. The first column stands for the number of senators which have no co-sponsorings with any other senator. The second column stands for the number of Zusammenhangskomponenten in our model. Measure 1, measure 2, and measure 3 are the calculated measures from the last chart. And the last column, this is the number of false senators. So the number of senators which have more co-sponsorings with the opposite faction than with their own faction. And we can make the plots for some different areas too. For example, civil rights and liberties and immigration. And as we can see, here we have low measure 1 and low measure 2, so a low level of similarity of the two factions. And in sports and recreation, we have a high value in measure 1 and measure 2, so we have a high level of similarity. And we can see this in the plot too. So the plots fit together with the measures. And it's very intuitive. So back to the table. In the green areas, we would expect a higher level of similarity, a higher level of dissimilarity than in the red areas.